Alrighty, so let's do some more rocket science here, okay? My first step is let's figure out our initial and final masses, right? So the initial mass is just the rocket mass, right? With all its fuel. Now my final mass is going to be, we take away the fuel, right? So the final mass minus 282, that's just 80.0 kilograms. That's our final mass. Okay, so once you have the initial and final mass, we're set here, right? So just understand that the fuel burns and the rocket gets less massive, right? The next thing is to figure out the thrust of the engine. And this is, apparently, this is what people do wrong most often. It just seems like when I go back and like, where did they go wrong? Okay, so let's be careful here. We're going to do force times time is mass delta V, right? But this mass and this time have to go together. And we've got this mass, and this mass running around, right? Okay, so what I'm going to do is you have to use the mass, whatever mass you put here, this must be the time it takes to burn that fuel. So I'm going to go 282 as the mass and 35 seconds as the time. Okay, that looks like this. So some force times 35 seconds is equal to, in that time, I burned 282 kilograms, right? With a delta velocity of 869. Okay, so now I have to very carefully go 282 times 869 divided by 35. And that is 7,001.657 newtons. And that's the thrust of the engine. Okay? Now the next thing is, and this can't be underrated either, right? Let's find the initial weight, the force of gravity to begin with. I don't know what to call it, the figgy. Okay, and that's going to be 362 times 9.81. And that's 3551. And then the final mass, the force of gravity final, the fig of, I don't know what to call these, okay, is going to be just this 80, right? We're going to use the 80. So it's going to be 80 times 9.81. What is that? That is 784.8. All right, so now we are set. We can set up our Newton's second law, right? So initially we've got this thrust, the 7,001.657 minus this weight here. Equals 362, the initial mass, right? Okay, so many things you got to get right, times acceleration. Okay, so I'm going to go this guy, 7,001, minus this guy. That's 3450 is the net force divided by 362. And that's 9.5. My little Mac is taxiing for takeoff here. 9.53 meters per second squared. Okay. All right, and then finally, at the end, two things change, right? There's less force of gravity and less inertia. So we still have 7,001.657. So we're pretending that the engine doesn't warm up, right? Like this Macintosh is. And then 784 is the force of gravity. And then that equals 80 times A. Okay? Okay, here we go. Let's do this before the Mac crashes. Okay, 7,000 minus, let's see, 784.8. That's 6216 divided by 80. 77.7. The final acceleration is a not human sustainable 77.7 meters per second squared. Ta-da! All right.